They set up the local generator.
Hopefully this will work out for some time later. We can. I'm almost there again, so. Okay, I want to come back to this picture with this higher level abstract view in the simulation workflow we are looking at, and the focus on this ETL processing here, so aggregation, complex transformations that are not really visible in this picture, but imagine that this covers various activities in the real workflow here. So we may want to address the complexity of this processing again. So perhaps some further abstraction is needed, and with this further abstraction that we have provided in our framework, also some kind of optimization decisions is possible here. In this concrete example, optimizing this ETL processing is also reflected in this overview picture. So if we identify that all these data preparation steps can be done in parallel, MapReduce-based service could be appropriate to implement this kind of processing, and this of course fits very well into the overall picture here. But how do we decide that? And can we automate these optimization decisions? And this can be part of another aspect implemented in the framework. We also provide some pattern-based modeling of these data management aspects. So this is an extension of these basic activities, and those patterns are transformed into executable workflows by means of a rule-based pattern transformer. And what we envisage is that this rule-based pattern transformer, of course, the first purpose is to go down the pattern hierarchy from a very abstract definition of the data management activities to the executable ones. But at the same time, we can include this kind of optimization decisions, so which is the right infrastructure to run, for example, this complex ETL processing. This should be part of this transformation process as well. Outlook, what we did not really tackle so far, so the other parts of the framework I presented are available. What we did not tackle so far is very important aspects of traceability and reproducibility, which is a core issue also for scientists. If they run this kind of simulation workflows, they really want to know what was processed by which part of the tool, and they also want to have some kind of repeatability of the entire process, to control the experiments, to repeat them, to improve them. And this means, for example, some kind of comprehensive tolerance framework is needed here, but we have not yet looked into the specific details related to this simulation project. So let's conclude here. I try to focus on some specific aspects of simulation workflows, in particular to data management, illustrate how this simulation workflows can be deployed in the cloud, and what this framework developed in our project provides as support for abstract and generic data management for this kind of simulations. So thank you for your attention.
Time for some question.
Hi, I'm Daniel from Technical University of Vienna. You show a lot of interesting things, but as you talk about simulation workflows, I did not get if and how do you manage performance issues. And also in the examples showcased on the slides, you show very little amounts of data, 120 megabytes, 2 megabytes, which might not be the case in a scientific workflow. Have you had any engineering of the application before deploying in the cloud in this way, or at least using cloud database so that it can be deployed? Or is this just something that you have in a conceptual way?
So this simulation tools themselves are provided by some other project partners. So this is existing software, and they considered these issues of data volume already. So they can be deployed and work on data of various size. So this is in practical use.
Yes, but I mean in Stuttgart and HLRS you have 7 petaflops of computing power, you can generate petabytes of data, and I still can't see how you can translate that in a cloud database, and because the performance issue is very oscillating.
Okay. To admit for this example, we do not work with this high-end infrastructure, because the focus here is on simulations that are done by organizations that do not need this dedicated specialized infrastructure, but that can be deployed on sufficiently equipped clusters, and that's what we do. Thank you.
Okay, so let us close the session. Thank you very much. Because we start a little bit late, so we also have to renew the coffee time as a consumer.